this is Mr. Yao. Today we're going to talk about 4.2, where we'll learn about domain, range, and end behavior of functions. First, let's look at the definition. Domain means all the possible x values, input, independent variable, or when we look at the graph, it's from left to right. Range means all the possible y values. We can also call it output or dependent variable, and when we look at the graph, we're looking from bottom to top. As for the end behavior, it means how a graph acts or behaves on either side. And we are talking about the end. So for example, if we have a parabola, we are talking about these two tips on the left and right and see how they behave. Now let's have a look at some examples. Example 1. We're looking at a graph and we're trying to decide on the domain or range. I like to draw some extra helping lines. So for domain, I prefer to draw some vertical lines from left to right. So I'm going to start drawing like a vertical line everywhere on the graph. I'm just moving from left to right. And I'm trying to see if I'm hitting part of the graph. If my vertical line is crossing any part on the graph. If it actually crosses, that means I do have a value on the graph, an x value. So for this graph, you do need to understand it actually never ends on both ends. So if I actually go all the way from the left, which is negative infinity, I am still crossing the actual graph. So it's negative infinity going all the way to the right, positive infinity for the domain. Range. For range, I prefer to draw some horizontal line. And again, if I draw a line there, it looks like it's not touching, but if I actually extend the graph, it is going to cross the graph. So I'm going to draw a bunch of horizontal lines, and I can see, oh, I'm actually hitting the graph. So it's from negative infinity to positive infinity again. And that's why for domain it's important to know it's from left to right, and for range it's important to know it's from bottom to top. Next, end behavior. Let's talk about the left end first. We have a new notation, which is limit. We use LIM to represent limit. Then on the bottom, we will write x arrow negative infinity. That means when x is approaching negative infinity. So when x is going to the negative infinity, that means x is going to the left. We're trying to see how the y is behaving. And apparently, since my graph keeps on going down, my y is going down as well. So that is going to negative infinity. Then we also have the other end is when x keeps moving to the right, goes to the positive infinity. I can see my y is going up since my graph keeps on going up. So my y, the whole thing, is going to positive infinity. That is end behavior. Now let's look at a few more examples. Example 2. Domain, I'm just draw a bunch of vertical lines. And I'm hitting graphs everywhere, and it never ends on either side. So it's infinity, positive infinity. Next, I'm going to draw a lot of horizontal lines. So here's the tricky thing. We have this dotted line. The dotted line is actually called the asymptote, which you should have heard of before. It actually means the graph is not crossing that line, it's actually getting close to it. So I actually draw a horizontal line there. It's not crossing any part of the graph. It keeps on moving up, still not crossing. And even if my line is exactly on that horizontal line, that dotted line, because it's asymptote, the graph is not crossing it or touching it. So even though that value is -3, since I'm not touching it, I cannot include that value. That's why it's going to be parentheses, not square bracket. And if I keep drawing my horizontal line, it goes all the way up to next, end behavior. So my x can keep on going to the left, so still going to negative infinity. But when I think about my y value is not even crossing this line, this asymptote. So the most I can go is to as close to -3 as possible. As for the right end, as my x go to the right, my y keeps on going up because my graph is going, so it's going to be infinity. Example 3. Same thing, let's draw some vertical line for the domain. Actually hits everywhere, so it's from negative infinity As for the range, I draw a line there. It's not hitting anything, not hitting anything, until I draw a line exactly on that point. It's hitting the graph, so it's from -2. And since I'm including that point, the square bracket going all the way up to +50. And the end behavior, look at the left end when my x is going to -infinity to the left, my graph is going up, so it's +infinity. And same thing for the right, if my x goes to +infinity, to the right, my graph keeps on going up, so it's going to +infinity. Example 4. This is slightly different. So we know the right end, it keeps on going, but left end, it actually stops right there. It doesn't keep on going to the left. So for domain, if I draw a line, a vertical line right there, I'm not hitting any parts of the graph until I start drawing my vertical line right there. Then I'm actually getting to the graph. So my domain starts from 4, because that's the x value for this starting point, going all the way to the right to infinity. And then when I draw a horizontal line, I'm not hitting anything, nothing, until I actually draw a line right there on that point. I'm hitting that point. And that is at 1. So if I keep going up, I am going to get to +infinity. As for the limit, this is slightly different again. I'm going to deal with the right one first. Because the right one, if my x keeps on going to the right, my graph is going up, so it's going to be +infinity. But the left one, my graph is not going to -infinity. The most it can go is actually right there. That's the most my x can actually go, which is -4. So instead of going to -infinity, my x is going to -4. And the other thing is, since it's the left end, that means I'm moving from the right to get to the point on the graph. So we use a plot sign on the top right corner to indicate I'm moving from the right. And the most y value I can get to is actually a 1. That's why the end behavior for y is going to 1. Example 5. Domain, drawing vertical line. And you might be thinking, oh, if I draw these lines, I'm actually not hitting any part of the graph. But like I said, these graphs keeps on going. And as long as the graph keeps on going to the left and the right, you are going to hit it. It's just going to be a very big number that we cannot see on the graph. Domain still starts from -infinity to +infinity. As long as the graph tilts a little bit to left or right, we are going to start from -infinity. For range, nothing until I actually draw my line right on the x-axis. I'm actually getting points. That is starting from 0 all the way up to +infinity. As for the end behavior, we have two notations, 1 to the -infinity. So if I keep on going to the left, the graph is going up. It's infinity. And if I keep going to the right, graph is going up, so it's infinity again. Example 6. Domain, same thing, draw a vertical line. And I'm hitting graphs everywhere, and remember these keeps on going. So from infinity to infinity. As for the range, I'm going below nothing until I actually draw a line right at -4. My range is -4, +infinity. Behavior, when x approaches infinity, my graph keeps on going up, so it's going to +infinity. And when my x goes to infinity, my graph keeps on going up to +infinity. Example 7. Domain, same thing, away from the left to the right, any line I draw, -infinity, +infinity. Range, if I draw a line there, nothing. Even if I draw a line on like -10 exactly, it's nothing. It's just slightly above. So I'm gonna estimate and say that is -9.9. And then it keeps on going up to +infinity. As for the end behavior, it's actually the same as the previous question. When going to the left, -infinity, my graph keeps on going up to +infinity. And when I'm approaching infinity to the right, my graph keeps on going up to infinity. That is everything for 4.2. Thank you.